Applications of trig functions. This is 5.8, day 1 and 2. So what we're going to do is use everything that we've learned about trig functions and apply them to different problems. So example 1, we're given this triangle and we are going to solve it. That means find all the missing sides and angles. So we're going to start off with angle A. This will be 41.5 degrees. And then little b will be 20. So we have to find angle B, little a, and little c. So we know that all the angles of a triangle have to add up to 180. So if you would add 90 and then 41.5 and then take that sum and subtract it from 180, that would give you angle B. So that means that angle B is 48.5 degrees. I should show this. You subtract that from 180. Okay, then we're going to find little a and little c. So I'll do little c first. If you notice, this side is adjacent and this is our hypotenuse. So I'm going to use cosine 41.5 degrees equals adjacent, which is 20, over my hypotenuse, which is c. So I'll multiply both sides by c. And then to get c by itself, I'm going to divide. And I forgot to mention, make sure your calculator is in degree mode. And if you put that in your calculator, you're going to get little c is 26.70 units. And my last side that I'm going to find is A. If you notice, A is opposite and 20 is adjacent, so I'm going to use tangent equals opposite over adjacent. Multiply both sides by 20. Put that in your calculator and you're going to get A, or I put O, but little a is 17.69 units. Example 2 has two triangles in one, and they want us to find the length of x. So I'm going to first look at this triangle here, and notice they gave me angle 20 and an adjacent side, and I need this side here, which is opposite. So I'm going to use tangent 20 degrees equals opposite over 100. Multiply both sides by 100. Put that in your calculator and you should get 36 units. So far we have this side is 36. Then I'm going to use this triangle, and I have my adjacent side, which is 100, and then I have to look for my opposite side. So basically the same thing. So I'm going to do tangent 8 degrees equals opposite over 100. I'm going to use the same process. 100 times tangent 80. And now I'm going to get 14. So since they want this entire length, we have to take 36 plus 14 to find x, which means x is 50 units. Now, in example 3, we're going to talk about navigation and people that have to use navigation to help them get from one point to another. We use the word bearings to help us specify the location. Bearings have 3 parts. You have a letter, and you're going to use north or south, whichever one is closest to. You can have an acute angle that is formed with the north or south line. And then you have a letter east or west. So I have this picture here. And we'll look at example 3A. They want the bearing from O to B. Now, if you notice, O is the center and B is the point we're trying to get to. So B is closer to the north line. So when you write it, remember it's 3 parts. So part 1, we know is closer to north. The angle that's formed with the north and this bearing line is 40 degrees. And then we are going to, or getting closer to, the west side. So to describe O to B, you would say north, 40 degrees west. B. Now we're going to go, let me erase that line, the bearing from O to A. Okay. Now we are still close to the north line, but we don't have that angle. We know that it's 20 degrees for this little one, and it's forming a right angle, so that means this little angle has to be 70. So we say north, 70 degrees, and now we're closer to the east side, east. C, the bearing from O to D. Now we're closer to the south side, and the angle that's formed from the south line to D is 25 degrees. So we say south, 25 degrees, and we're getting close to the east, or we're closer to the east side. And then the last one, the bearing from O to C. So we're still close to the south line. The angle that's formed from the south line to C, we don't have, but we know this angle is 75, and 90 minus 75 gives us 15 degrees. So south, 15 degrees, and now we're closer to the west side. So that's how you describe a bearing. So in example 4, we're going to use bearings to help us solve this problem. It says a boat leaves the entrance to a harbor and travels 40 miles on a bearing of south 64 degrees east. So if you notice, I am drawing my north, south, east, west line. And I'm traveling, here's my harbor. I'm traveling 40 miles south 64 degrees east. So that means this angle here is 64 because it's the angle with the south line. And they want to know how many miles east from the harbor has the boat traveled. So I'm really making a right triangle. So they want to know east, and they want to know south. Now notice this angle in my triangle I don't have, so I have to do 90 minus 64, and I'll get 26 degrees. So this is how my triangle looks. So I need to find the adjacent side and the opposite side. So first I'm going to use cosine. Cosine 26 degrees equals adjacent over hypotenuse. Multiplying both sides by 40, you should get 36 miles east. And then let's do my south line. Now I'm going to use sine. 26 degrees equals opposite over hypotenuse. Multiply both sides by 40. And then you should get 17.5 miles south. So simple, for example 5, simple harmonic motion. When you think about music and looking at measuring motion, we have this equation which looks like our sine and cosine equation. Where A is your amplitude, so the absolute value of A is your amplitude. And then your period is 2 pi over W. The frequency, which is the cycle or how often it repeats, is given by this formula, which is W over 2 pi. And remember, 2 pi is your period. So it says, an object in simple harmonic motion has a frequency of 1/4. So F is 1/4. Oscillation per minute and an amplitude of 8 feet. Write an equation in the form D equals A sine WT for the object's simple harmonic motion. What we don't have is W, but we can find it using the frequency equation. So 1/4 equals W over 2 pi. Now what I do is I cross multiply, and I just solve for W. So W equals pi over 2. Now we have everything we need for our formula. So I have my amplitude, which is 8. I have W, which is pi over 2, T. And there's your equation.